Welcome back to the instructional video series on hierarchy of energy theory, where we unify all physics under one big, beautiful model. I am your theory influencer, Scott Gordon. If you're joining us for the first time, please go back and start learning hierarchy of energy theory from lesson 1 to get the most out of this and future lessons. In this segment, we apply the knowledge we have already learned from hierarchy of energy theory to questions that have puzzled physicists for decades. And before we get started, I'd like to point out that one of the many strengths hierarchy of energy theory has is that it doesn't just solve one or two problems. Since it starts at the most fundamental level, it solves a multitude of problems as its physical model is advanced. And we're just getting started. The first question we'll tackle in this lesson is one that most people don't even think about. What determines the property of straightness? As we look outwards to the heavens, we think that the light reaching us has traveled straight, unless it was manipulated by objects along its path, as seen with the formation of Einstein rings. We have been using the property of straightness somewhat loosely without really defining it. But let's take a closer look at what hierarchy of energy theory suggests when it comes to a linear path and what determines a path as straight. Let's look at a photon moving through a region of spacetime that has the same energy density along all its independent energy directions. Equal energy along the path of a photon defines this path as straight, where a photon will not deviate to one side or the other. But what would make a photon deviate? Well, I'll tell you. As a photon moves through spacetime, the photon's energy field encounters energy densities along its path. The speed that the photon's energy moves through spacetime's energy is the speed of light. But what if the spacetime energy along the photon's path is greater on one side compared to the other? Well, a different energy density along a path in spacetime means different relative quantum distances. The side with more energy density would have relatively shorter quantum distances. The photon would deviate to the side where the underlying spacetime energy density along the path is increased. Okay, well, that's simple enough. But here's the crazy part. What if we are looking into a region of unequal energy spacetime? Would we be able to tell? And that answer is no. We would not be able to detect a curved path in spacetime because as far as we know, a photon moving along this curved path would be what we would consider as light moving straight from our perspective. We need to realize that the parameter of straight is a relative property. In addition, as we advance hierarchy of energy theory to include the energy of the second energy tier, and that would be energy associated with mass, we will see that it doesn't matter what energy tier the energy along the photon's path is. It's the total energy along the path of a photon that determines the relative quantum distances and relative quantum time units. Hierarchy of Energy's model tells us that spacetime's geometry is a result of its energy content. This includes the energy of all the coexisting energy tiers within spacetime. This model is consistent with the math of general relativity, where energy is related to spacetime geometry. But here's the kicker. Even when there's no mass present, there is no rule that says that spacetime's base energy is equal along all its independent energy directions throughout spacetime. As a matter of fact, this can't be the case, which brings us to our next question. Does our universe have a border, and if so, what's beyond it? Spoiler alert, if you are a believer in multiverse theories, your multiverse world is about to be shattered. Distance is created as more and more building blocks are added to the universe along with the required energy to add them. We can now picture a region containing building blocks, and within that region of energy, the properties of distance, time, and dimensions exist. But what is outside that region? As we go farther outward to where there are fewer building blocks and less energy density, we will get to the last building block. From this point and beyond, there is not enough energy to create even one quantum distance. Point still exists thereafter, but distance does not. And what does this mean? Well, I'll tell you. It means that if a photon is heading for this peripheral region of the universe, it will experience a curved path to bring it back towards the regions containing more energy. In other words, back into the universe. From our perspective, we just see light coming at us thinking it's always traveled a straight path from its source. This is most likely not the case. We can now answer the question of what is beyond our universe. There is no distance beyond our universe. There are just points as discussed in Lesson 2. It could be fun to speculate that we can go around the universe reaching the other side in much less time than if we were to go directly through the universe. What about the question of whether there are other universes? Well, where would they exist? And what are you going to create them with? If you're creating another universe using our universe's building blocks, then no matter which point you choose to place the building block, it must still interact with every other building block already present in our universe, and thus be part of our universe. What if you're trying to build another universe from a different building block? Well, that would bring up a slew of issues. What is the nature of another building block? Would you place them in our void, or would there be another void to place these blocks in? Could there be another void? Would the energy of another building block or another void interact with the building blocks and energy of our void in our universe? I just think there are more important aspects of physics and cosmology to put our minds to, especially since hierarchy of energy theory tells us that we don't need any other universes to explain everything that's going on in our universe. And speaking of explaining our universe, we can now address the fascinating question of what the true void is. So we start with space-time and begin by removing building blocks until we finally remove the last one. As we do this, let's look and see what happens to the speed of light. Remember that the speed of light is a relative constant and will always be measured as a quantum distance per quantum time unit in space-time from a perspective within our universe. But from the outside perspective of space-time, as we remove building blocks from the universe, the speed of light relatively increases as the relative quantum distances relatively increase. The more building blocks removed, the relatively faster the speed of light becomes. When we remove the last building block, we are automatically in a perspective outside of space-time and would see the speed of light reaching infinite and yet be zero at the same time. But why? Well, here's why. In the void universe, distance no longer exists, so there's no place to go. Thus, the speed of light is zero. And at the same time, you're instantaneously everywhere at once. Or in other words, it takes you no time to get everywhere. Thus, the speed of light is infinite. How crazy is that? Let's move on to the issue of inflation and see why it's inflation that results in the redshift. Hierarchy of energy theory constructs spacetime using building blocks and energy. To construct a uniform, infinitely large spacetime would require an infinite number of building blocks and an infinite amount of energy. Besides the fact that this does not seem reasonable, inflation provides the evidence that this is not the case, since the redshift is a direct consequence of inflation. But what is inflation in terms of hierarchy of energy theory's model? We start with the initial conditions of the universe where there is not an infinite number of space-time building blocks. This means that the initial organization of building blocks would be contained within a region. And no matter where that region is, or what the initial alignment of the building blocks are, all the building blocks would repel from each other. This repulsion of building blocks results in the building blocks moving relatively farther away from each other. The relative quantum distances would increase, and they would continue to increase forever. Now, how do we know that this inflation is occurring? Because this process directly results in the redshift. As inflation occurs, the quantum distances and the quantum time units increase. And the energy associated with a relative quantum distance decreases as the relative quantum time units increase. Planck's constant remains constant, as was shown in Lesson 6. It also incorporates the increasing relative quantum time unit within its constant value. The relative increase in the quantum distance of a photon's wavelength becomes the basis of the redshift. In essence, the redshift is a measure of how long a photon has been traveling through space-time. As the space-time of the universe inflates and its relative quantum distances relatively increase. Hierarchy of energy theory's model for inflation also tells us what dark energy is and what the cosmological constant represents. Because of inflation, spacetime cannot have equal energy densities as it extends infinitely outward. Because the energy of the spacetime energy medium is not equal everywhere, there exist gradients in spacetime's energy. The energy gradient created in spacetime's energy is what we refer to as dark energy. Energy gradients result in objects being accelerated from regions of higher energy density to regions of lower energy density. Inflation of spacetime results in these energy gradients. Note that the movement of spacetime itself does not create forces on objects in spacetime. It's the energy gradients that develop that create the forces on objects in spacetime. We cannot directly acknowledge the energy gradients of spacetime because we cannot determine the energy density within any region of spacetime. In addition, the laws of physics and the physical constants remain the same, no matter what the energy density is in a region of spacetime. Because of this, many physicists reason that expanding spacetime is the same before and after it expands. This is not the case. And to say that this is the case means that there would be no energy gradients in spacetime, thus leaving us with the problem of dark energy. And this brings us to the cosmological constant. The cosmological constant represents the energy gradient within spacetime. Hierarchy of energy's model of spacetime tells us that the cosmological constant is not constant. It varies with time and position within the universe. Another interesting aspect of hierarchy of energy theory's model is that it tells us what caused the Big Bang. Yes, you heard that right. It tells us what caused the Big Bang. Hierarchy of energy theory's model starts with two ingredients to create everything in the universe. But how did these two ingredients come to create the universe and everything in it? Well, I'll tell you. All we need to do is set the correct initial conditions of the two ingredients, then watch the inevitable outcome. What I'm about to say is going to seem a bit ironic and possibly put a little smile on your face. Why? Because I'm going to show that a phenomenon that has already been described by physicists as a doomsday scenario called the vacuum decay phenomena is what, in a twist of fate and irony, actually created the universe. Basically, a vacuum decay phenomenon is where the universe is in a false vacuum state and then transitions to a true vacuum state. During this process, everything in the universe is destroyed. Now, why no one ever thought of this process as the process that created our universe, well, that's the part that makes me smile. Anyway, the initial conditions proposed in hierarchy of energy theory aligns the building blocks of spacetime to create the two spatial dimensional universe. In this universe, there is a potential independent energy direction or dimension that is still available. If you want to call it a hidden dimension, be my guest. As inflation of the two-dimensional universe occurred, it became unstable and found an entirely new dimension for energy to align on. The independent energy direction axial to the plane of the two-dimensional universe. This process represents a higher vacuum energy state finding a lower vacuum energy state. It's the very definition of a vacuum decay phenomena. What physicists propose as the end of the universe could have been proposed as a way to create the universe. During this vacuum decay phenomena, conditions were created that accelerated some of the spacetime's building blocks to the speed of light. These building blocks made the jump to the first energy tier, creating the primordial photons. So, hierarchy of energy theory tells us that in the beginning, there was light. Now where have I heard that before? We should also realize that light had to be created first, since this was the first energy tier for energy to jump up to. During the unique environment of the Big Bang, all the primordial photons created by the acceleration of building blocks had to lead with the same electric charge associated with compression. It was these very high energy primordial photons colliding during a vacuum decay phenomenon that provided the environment for energy to jump up to the second energy tier, creating particles that contain mass. This unique environment, which cannot be recreated in any collider, leads us to a potential answer as to why the universe is composed of matter and not antimatter. These primordial photons collided and created both matter and antimatter. But because all the primordial photons were compression-leading photons, thus leading with the same electric charge, this could provide a good reason why the universe ultimately favored the creation of matter over antimatter. If all the primordial photons led with the opposite electric charge, the universe could be composed of antimatter. All right, let's move on to one more issue that is inherently solved by hierarchy of energy theory, and that is, why do our conservation laws exist? Yes, the mathematics of symmetry is all well and good, but there is even a more fundamental reason that hierarchy of energy theory offers. Recall that once a building block is accelerated to the speed of light, it becomes a photon. A photon that will move in space-time forever. The energy of the photon, or the energy of the first energy tier, can never return back to being the energy of space-time, the base energy tier. In addition, after the vacuum decay phenomena, or after the Big Bang, the energy of space-time could never again become the energy of light. Therefore, after the Big Bang, the transition of energy between the base energy tier and the first energy tier is no longer possible in either direction. The energy of particles in space-time must always remain as the energy of particles in space-time. The energy of space-time must always remain as the energy of space-time. And there you have it, the law of conservation of energy. So how do particles come to have charge and momentum and mass? Those are just some of the topics we will cover in the many lessons to come. Once the basic structure of the second energy tier particle is presented in the next few lessons, most people will have an overall general understanding of hierarchy of energy theory. However, physicists require much more detail, especially in mathematics. So after the next few lessons of laying out the basic physical model for particles of the second energy tier, I will be very specific in extracting our current mathematics from hierarchy of energy theory's physical model, including that of quantum mechanics and general relativity. I'd like to point out again that hierarchy of energy theory does not change any of our known math for our well-verified physics theories. It just provides us with a big, beautiful physical model that correlates with our current mathematics so we can finally advance physics beyond its current impasse. So hold on to your seats as hierarchy of energy theory takes you to the inner structure of our fundamental particles as we move to the next higher energy tier, E equals mc squared. If you are curious about this novel approach to finding the theory of everything, then click the like button below and subscribe to this channel so that you can be notified when future lessons are released.